when a resistor of 5 ohm is connected across a cell of EMF. See, this is the cell. A resistor of 5 ohm is connected across this. First one is resistor of 5 ohm is connected across this. And as it is, we have seen the resistance, internal resistance is given by L1 minus L2 divided by L2 into the resistance which is connected R, this resistance. This already we have derived it, where L1 is equal to, what is L1? Where L1 is the length when the battery, when this is disconnected, and the balancing length is L1 when it is connected, and the balancing distance is L2, and R is the external resistor. First, what we will do, first we keep it as L1. There are two cases. This we will keep it as L, this as L1 and this as L1 for the first cell. First we are connecting 5 ohm, again we are connecting 10 ohm here. So this is the balancing length, where L is equal to balancing length without or connected across this, across the cell, and this is L, because both the times the resistor, this resistor only changed, this cell is not changed, so therefore the balancing length for the cell when it is removed will be same. When without this we balance it, suppose we balance it at this point J, at this point we balance it at this point, this length is equal to L. That is, the L stands for balancing length without R connected across the cell. Without R connected, this is the balancing cell of the cell, balancing length of the cell. So this gives only the EMF. This length gives the EMF of the cell. Only EMF of the cell, not internal resistance. Only it gives the EMF of the cell. So second, now we are connecting a cell R. We are connecting a R which is equal to 5 ohm. 5 ohm we are connecting. Now we are obtaining a balancing point. A balancing point. Now we are getting a balancing point, say somewhere here. What is the balancing point? Balance 150. 150. Say about this is 150. When we connected it, J1, jack is moved. When both are connected, this is the length. We call it as L1. We call this length as 1. It means what? When with the cell a resistance is connected across it, and we balance it, getting the null deflection here. Null deflection for balancing. It means it is balancing that length is L1. L1 is equal to balancing distance on the potentiometer wire with R1 is connected, where R1 is equal to 5 ohm. In that case, L1, what is L1? Where L1 is connected across cell, and a 5 ohm balance length is 150 centimeter. 150. So this is equal to 150 centimeter. This length. Because when this we have to remember, when this is not connected, the balancing length will give the EMF. When this is connected, then this will give the terminal potential difference. It means this potential, terminal potential, that is terminal potential difference V. It will show the terminal potential. When it is not connected, this will show only the EMF. This difference you must always remember. So we can say R1, we got the R1 is equal to 5 ohm. 5 ohm. So what is R in the first case? First case, R is equal to L minus L1. L1 is equal to 150 divided by L1, that is 150. 150 is into R is 5 ohm. 5 ohm. That is 150 divided, 150 goes on the top into 5R is equal to L minus 150, that is 30R is equal to L minus 150. First we got this equation. Now when a resistor of 10 ohm, now R2 is equal to 10 ohm. R2 is 10 ohm connected. 10 ohm is connected. Now first we will find out what is the, we will find out the open. We will open it. Since the battery is same, we will get the same this length as L. So in the second case, this is for the first case. The second case, L as it is we get same. Why we get same? Because only this resistor which is shunted, it is only changed. The battery is not changed, and when in open condition, the balance length, this length will show the EMF of the battery, and that length is L. L is same. And L1, what is L1? Sorry, it should be L2. Second case, L2. The balancing length seems to be 175 centimeter. It means the balance L is 150. Now it seems to be 175. We call this position as J2. This length is 175 centimeter. So L2 is equal to 175 centimeter, and R2 is equal to a resistance of 10 ohm. So now 10 ohm is connected. When 10 ohm is connected, resistance of 10 ohm is connected. First, without this we get the EMF, but with this one we get the terminal potential difference. So this is the term. So we got this R2. Again we will put it in the same equation. R is equal to L. L is same for both the condition, and L2. L minus L2 divided by L2 into R2. This is the internal resistance, because the EMF of the battery does not change. Internal resistance does not change. Only thing, the shunting resistance changes. With that we brought one equation. We will go for the second equation also. Therefore R, internal resistance, is equal to L, and L2 is equal to 175 divided by 175 into 10. Or we can write 175 by 10 is equal to L minus 175. That is, we can write it 17.5 into R. 17.5 into R is equal to L minus 175. This is the second case, L minus 175. This is the second equation. This is the second equation. So from this we can find out. So this is the first equation is 30R is equal to L minus 150. Second equation is 17.5 R is equal to L minus 175. Subtracting this both. When we subtract this, 13 minus is equal to 12.5. R is equal to this, and this get subtracted 0. This become plus. This become 25. or R is equal to 25 by 12.5. 12.5 is equal to 2 ohm. Therefore, the internal resistance of the battery is equal to 2 ohm as per the given condition.